This is the last of the sequences and series stuff. So this is infinite geometric series. So for example, we've got a series that we've looked at before in the previous lesson. So it should be the sequence first of all, and then we're going to work a series out from it. So a third, a ninth, 1/27th, 1/81st, etc. So if you remember, A was a third, and the ratio is 1/3 as well. And so we worked out the sequence to 9, and this is what it was, 1/3, and bracket, and then we got that. So remember on the calculator, that's how we worked it out. Now for a certain series where the ratio is a fraction, or should I say modulus of the size of that ratio is between 0 and 1. So whether that's negative or positive, that doesn't really matter. But what happens is each term here gets smaller and smaller and smaller. So you're adding smaller and smaller amount all the time. So this was the sum we got to 9, 0.439 and a 7. Now, if and I'll show you something in your calculator, what you can do is you can take all of that and you can go edit, copy, paste, and I'll paste it down here. And so say, for example, we change that and say we want to say the sum to 15. And then we do that. And so have a look at that. Now we've got some more 9s. And so say, for example, we go bigger again. Copy that, put it down here, paste. Let's say go to 20 now. And we've got even more 9s now. All right, so when you look at those sums to 15 and to 20, so we've got sum to 9, sum to 15, sum to 20. So as it appears, as n gets bigger, goes towards infinity, that the sum is heading towards 0.5. So, if I go back here and I'm saying I'll copy that and paste that. Let's change that to say 50. Then our calculator does say that it's 0.5, so it's exhausted the number of decimal places that our calculator can work out. So it would appear that as n goes towards infinity, the sum goes towards 0.5. So when we say this, this happens, the series is said to be convergent. So it's converging. So what it means is that the more terms that you're taking in your series, then the value of that sum of all of those terms of the sequence is converging on a number, and in this case 0.5. And so, as I said, R has to be between 0 and 1, the size of it, so between -1 and 1. So the limit of a convergent series, before I get to that, so what with this particular one here, that limit of that series, we can actually write it in a funky mathematical way. N equals 1 to infinity of A, which is 1/3, times R, which is 1/3, to the n minus 1. So, and that becomes 0.5. So that's the funky mathematical way of writing this. All right, now to work all of that out is quite time consuming. So what we have is the limit of this convergent is called the sum to infinity. So S infinity, as it says there. And again, your textbook shows you this, but you get A times 1 minus R as being the formula that you would use. All right, so let's have a look here. Sum to infinity of this series. So the first term in the series is a half, and the ratio, common ratio, is also a half. Remember, you can figure that out by taking a term and dividing by the one before it. So the ratio is a half, so we're asked the sum to infinity. So the sum to infinity is a over 1 minus r, and so that's a half over 1 minus a half, which is a half over a half, which is 1. All right, so what we can do is we can use this sum to infinity, as before, earlier, when we just were doing in the prelude, in the step-up stuff, when we were just doing some arithmetical kind of stuff, we can use this to express recurring decimals as a fraction. So this recurring decimal, 0.32, of course, is 0.32, 32, 32, 32, 32, and so on. So if we think that, then I'm going to split it up into bits, the 32. So it's that 0.32 plus this next 0.32, which of course is in the third and fourth decimal places, plus this one, which is of course in the fifth and sixth decimal places, and so on. Now, you can think of this then, this is a series, 3, 2. This is a series, geometric series, because if you take one term, divide it by the one in front, you'll get the ratio. And your first term, of course, is A, and your ratio, if I go, is 0.0032 over 0.32, which is 0.01, and A is 0.32. And so what we can do is we can say then that the sum to infinity of all of those is A, which is 0.32, over 1 minus R, which is 1 minus 0.01, which is 0.32 over 0.99. Now we're asked to express it as a fraction, not as a decimal. So what we can do there is we can say, okay, well, we've got decimals here. I want to move that decimal place. I can move it 2 places to there if I times that by 100. And of course we need to times the bottom by 100. And if we did that, we get 32 on 99. All right, so use convergent series or an infinite geometric series to find out the sum to infinity is. All right, so of course remember though, the key thing is that the size of R has to be between 0 and 1. All right, for this to occur. So if it's not that, then it doesn't converge. It just keeps getting bigger and bigger and bigger and bigger and bigger. All right, so that's the last bit of the sequences and series. So we'll be having some sort of assessment on this soon. And as always, have fun. And if you need help, make sure you get back to me.